plus A1 into distance of its CG from neutral axis, its square, that is nothing but 1 by 12 B 100 into 20 cube, plus the area of that particular first rectangle, that is the 100 into 20 multiplied by distance, that is 32.23 minus 20 by 2, that is 10 whole square. We HUI1 as 1055012.5 mm raised to 4. Now let us we found out the value of I2. Now please on this tabletop. Now if you are referring this T section, I want to find out I2. What is IXX for the second portion? This is nothing but 1 by 12 BD cube. Here this is my B and this is my D. B is 20, D is 80. 1 by 12, 20 into 80 cube, plus area 20 into 80. H2 square. H2 is nothing but, this is my CG of the second part, and distance between these two is H2. How to find out H2? If I want to find out, H2 is equal to 67.77 minus 80 by 2, that is 40. This is my H2. So if we are referring the same thing on this PPT, I2 is the, refer to the PPT, I2 is the moment of inertia of the wave about neutral axis. So moment of inertia of the wave about an axis passing through its CG plus A2 into distance of its CG from the neutral axis square. As we discussed, it is 1 by 12 BD cube, 1 by 12 20 into 80 cube, plus area, that is of 80 into 20 1600 into H2 67.77 minus 40 square, and we obtain it, it's 209.9 millimeter raised to 4. So if we do the summation of I is equal to I1 plus I2, we got it some value, that is 314.22.4 mm raised to 4. This is the value of I for a given I section, given T sections precisely. So for a simply supported beam, the tensile stress will be at the extreme bottom fiber and the compressive stress at the extreme top fiber. So tensile stress at the bottom, compressive stress at the top. So maximum bending moment for a simply supported beam, we know it is WL square by 8. W load 1500 Newton per millimeter into 8 square by 8, we got it 1200 Newton into meter. If we convert the same thing in terms of Newton into mm, it is 1200 into 1000 Newton into mm. Now using our basic fundamental relationship M over I is equal to F over Y, to find out maximum tensile stress, and the maximum tensile stress will be at the extreme bottom fiber. So Y bottom is 67.77. We put the values F T is equal to M over I into Y T. So put the value, all these things we got, it is 258.81 Newton per mm square or megapascal. For maximum compressive stress, the formula is remain same, only we have to change the value of YC, that is the distance of the neutral axis from the topmost fiber, that is 32.23, and we achieve it is 123.087 megapascal. So I wish you have understood how to find out the bending stresses for specifically unsymmetrical sections. Now next session is about problems related to the strength of section. Now the strength of section means the moment of resistance offered by the section, and the moment of resistance is given by an equation M is equal to F max multiplied by Z, where M is the moment of resistance offered by the section, that is, it is maximum bending moment. Also, the moment of resistance offered by the section is maximum when the section modulus is maximum. Hence, section modulus represents the strength of section. So, with this general brief introduction, let us start with the solution of one of the problem. Refer the data. 3 beams having the same length, same allowable bending stress and the same bending moment. 3 important parameters. 3 beams having the same length, same allowable bending stress and the same bending moment. The cross section of the beams are square, rectangle with the depth is twice the width, and a circle. Find the ratio of weights of the circular and the rectangular beam with respect to the square beam also. Very good, interesting question which has been asked to you. The question is about 3 beams are there. Nothing has been stated about the type of beam. Let us assume simply supported all the 3. Subjected to same bending moment means external loading is also acting on same allowable bending stress. Same allowable bending stress, the words they have been used, and same length. Only the thing is that the cross section of the beams are goes change. First beam section is square, second beam its section is rectangle where depth is the twice width, so D is equal to twice B, and third is the circle one. Question is about find out the weight of circular beam to the rectangular beam, and another is weight of circular to the square beam. All the 3 cross sections are shown in this particular figure A, B and C. Let assume x is the one of the dimensions of a square, so it's remaining same on the other side. B is the width of section, so D is twice B, and the D is the diameter of the circular beam. So, the moment of resistance of a beam which is given by an equation M is equal to F into Z, where Z is the section modulus. As all the 3 beams have the same allowable bending stress F and same bending moment, therefore the section modulus Z of all the 3 beams must be the equal. How? The statement is very much important. Let us understood the statement with this tabletop. So, we know the equation M over I is equal to F over Y. If we simplify this one, M is equal to F into I by Y is equal to F into Z. So, therefore, M by Z is equal to F. Or if I will write down M by F is equal to Z. M is constant for all the beams. So, if I will give M1, F1 is equal to M2, F2 is equal to N3, F3. So, F1, F2, F3 for all the 3 beams are same. M1, M2, M3 all the 3 beams are same. It means that Z1 is equal to Z2 is equal to Z3. Now, if we come to this particular PPT, it stated that as all the 3 beams have the same allowable bending stresses with the same bending moment, so Z of all the 3 beams must be equal. So, now section modulus of a square beam, that is I by Y, I is known to us 1 by 12 BD cube divided by D by 2, that is 1 by 6 BD square, but B and D are the same. We got the answer as Z is equal to X cube by 6. It is interesting point. Z is equal to x cube by 6. Now the section modulus of a rectangular beam is I by y, that is of BD cube by 12 divided by D by 2. Now D is nothing but the twice B. If we are replacing over here B into twice B cube by 12 divided by 2B by 2, and if we simplify these things by putting D is equal to 2B, we got Z is equal to 2B cube by 3. So we got section modulus of the rectangular section is of 2B cube by 3. Now about the circular section, section modulus of a circular beam is of I by yz, that is Z is equal to I by y, that is pi by 64 d raised to 4 divided by D by 2. We got pi by 32 D cube. Now equating the section modulus of a square beam with that of the rectangular beam, we have an relationship between B and x. Please refer x cube by 6, x cube by 6 is the Z for square section, is equal to 2B cube by 3 is the section modulus of rectangular section. If we equated and simplified, we got B cube is equal to x cube by 4 and we achieve 0.25 x cube. So we got B is equal to 0.63 x. This is the relation. B is the width of rectangular beam is nothing but 0.63 times the width of the square section. Now equating the section modulus of a square beam with that of circular beam, we got x cube by 6 is the section modulus of square section is equal to pi by 32 D cube. So D cube is equal to 32 x cube by 6 pi. Simplified it, we achieve D is equal to 1.1927 x. Diameter of the circular section is 1.1927 times one of the side of the square section. Equation number 2. Now what is our intention? Our intention is to find out the ratio of weight of rectangular beam to the weight of square beam. Now the weights of the beams are proportional to their cross sectional areas. Interesting observation. The weights of the beam are proportional to their cross sectional area. How? Let us be understood on this tabletop. Now what do you mean by weight? Weight is nothing but density or unit weight multiplied by volume, that is rho multiplied by volume. Volume is nothing but the length multiplied by cross sectional area. So for the first section of specifically square section, rho into length into cross sectional area. For second, so if I will write down for square section, it is rho 1 L1 A1. For rectangular section, rho 2 L2 A2. For circular section, weight is equal to rho 3 L3 A3. Now in all the three cases, they made up of the same material. Rho is same. Length is also same, has been stated. This is same. Only changeable parameter is area. So I will use the word in our problem, weight is directly proportional to the cross sectional area. So if we come to this particular PPT, weight of the rectangular beam divided by the weight of the square beam is equal to the area of rectangular beam to the area of square beam. what will be the area of rectangular beam? That is B into D. That is B into D. D is twice B. So 2B square. Divide by the area of section square beam, that is x into x, x square. We already know that B is equal to 0.63x. If we are replacing over here 2b square, that is 2 into 0.63 bracket whole square divided by x square. Simplifying this using the calculator, we found out the ratio is 0.7938. It means that weight of rectangular beam is equal to 0.79 times the weight of the square beam. Means if we are using the rectangular section, weight will be reduced compared to the square beam. Next one. Here our intention is to find out the ratio of weight of circular beam to the weight of square beam. We know that the weight of circular beam is proportional to the area of circular beam. So the ratio is equal to the area of circular beam to the area of square beam. What will be the area of circular beam? That is pi by 4 d square. Area of square beam x square. By simplifying this, we achieve pi by 4x square into d square. Now we know the relationship between d and x. D, that is the diameter of circular beam, is equal to 1.1927 times the one of the side of the square beam, that is pi by 4 d square. We know it the value 1.1927x square, and we found out by simplifying this, instead of this x it is pi, 1.1172. So the weight of the circular beam is 1.1172 times the weight of the square beam. So how we have used the concept of the strength of section and how we have solved the problems, look it out over here. Let us we go and switch to the next problem. Refer the data. A beam is of square section of the side A. Square section